what we were doing. So this was what we were doing yesterday, right? Like we saw some concepts around regression, the loss functions. What are the loss functions? Lasso regression and ridge regression, their use case, why they are used, right? Basically, the concept of overfitting, right? So today we will
Yeah.
be following with that and seeing some code related to that. Hopefully you got the yesterday's concept that we discussed, right?
Yeah.
Okay, cool. So just I will give you a quick overview. So basically we'll start with some basic imports. And for the purpose of just experimentation, import libraries. These are the basic thing that you do. For the data we require, right? So for what we will do here is we will try to generate a synthetic data set, synthetic data for understanding the concepts, right? Basically
Okay.
the linear equation and the quadratic equation and all those. After then we will see some linear regression, right? And we'll see
Yeah.
some polynomial regression with degree 2. Along with that, we'll see some overfitting, ridge regression. Any doubt you had regarding us yesterday's concept that we discussed?
I feel like you've given me the good introduction to it. On a normal day, I would go back to kind of do a bit of investigation on it. But I think if you could just provide a similar note to everything you kind of teach me every day or every week, maybe a note to say, okay, this is what we've done this week, because the plan now is after we finish this, then I can go
Mhm.
back later on. So just to make sure that there isn't any gap between our lectures. So once I want you to teach me everything, the deep learning, PyTorch, and all of those things. Once we do that, I want to pay you. Then we go into the project. So within the project is when I want to go back to
Mhm.
going back. So I need you to kind of create a note where I can always easily go back to, maybe at the end of the week or at the end of the day. So
Right.
now I don't want to go back. I want you to teach me everything I need to know, go through the project, then within the project, because I feel like so we are not wasting each other's time, so we can get everything done before the end of this month, if possible. If we're doing daily lectures, I think we should be able to. So I might not go deep, but during the project, I would rather want to go deep when I've started the project with you.
Mhm. Yeah, definitely. Like I will try to like share all the resources that we discussed in the session so that you can
Yeah,
go back, right?
yeah,
Go back to them after your session is done. So you have a good understanding there. So yeah, so I think we can just straightforwardly move with the code part. All right. And hopefully you are able to see my screen now,
yeah,
right?
yeah,
Okay, cool, cool. So just we will start from these things, and we will so basically as we discussed, like we will start from the understanding these NumPy code. So you know this, right? We will import all these libraries like matplotlib for plotting your graphs, right? Sklearn for your scikit-learn, basically for your machine learning related tasks. So basically, it has all those models, all the algorithms that is needed for your data science tasks, right? And
yeah,
all the functions like train, test, split, sklearn processing, right?
yeah,
So you just write this code and you just run it, and here the random seed you would have used it, right, on your code. But
yeah,
this is for your repeatability, right? So um, the data that generated is the data that is selected is repeatable, right?
yeah,
After this, what we will do is we will generate a linear data. For that purpose, like we will create a synthetic linear data using a simple formula, right? That will be your y is equals to mx plus c, right? And we'll add some noise to it as well, so that it looks little realistic, right?
Yeah.
Basically, what this noise does is like it will mm, give it so here this equation, right? To this thing, 2 y is equal to m plus x, right? X dot travel. Basically, it will take this sample data here. This I will give you a probable. It will look something like this. These are x coordinates, and for here we are generating the y coordinates for each of these x points, multiplying it by this value and adding a this constant here, right? It will give you another y or the label, right? And it will give you a complete data set, right, for your test purpose. So again, here we are doing a train test splitting, right? So I think you now know it, like it is help the model to learn to your generalization, right? So it is generalized, your model is generalized, not specific to your specific data set, right?
Yeah.
Basically, in the new data, it will be able to uh, work better. Now, again, here we are using linear regression, right? So I will just use this linear regression function from your Scikit-Learn library. Here I've imported it, Scikit-Learn, not linear model. So this algorithm is already provided there. And here you will find a coefficient, intercept, R2 score, square root, right? So this will be your RMSE value, root mean squared error, right? The error term. Cool. So basically, you know that equation, right? So here, what happens after fitting is, so you run this, uh, your your data set in this linear regression. What this linear regression does, do you remember?
Yeah, so it's this is a linear regression that we've just called, and we're fitting it on our S train and our Y
Hmm.
train, which is we train it, yeah. So we take the result from our Y prediction, okay, our Y pred is equals to lean predict S test. So we kind of take the prediction from the S train and Y train to test on the S text.
Hmm. Right.
If you want to explain, but I think
And
that's how I understand it.
so basically your len dot, here we have created this object len. Basically, this is a linear regression object. So if
Yeah.
it have
Yeah.
now these two functions, fit and dot predict. Fit will require two parameter train data set and a y train data set. The y train uh, data frame, right? So basically, this contain your features and this will be your labels, right? So this is your independent variable. This is your dependent variable, right?
Yeah.
Now,
So
based
this,
on
this
this, it will
is
try, yeah.
confusing.
Hmm.
This is confusing because usually we would divide our. So I think I need to understand that part. This part I'm trying to ask, and if you could just send me a note at the end of this lecture about this particular part. So we take our data set, we divide it into X, and we divide it into Y. The X are the independent feature, which are the variables, while the Y is the is the target variable, which is the Y. So then we take the S, which has all of the features, we divide it into S train and S test. Is that right?
Yes. So,
Then we take the
come
Y.
again. Just I'm just confused. Yeah, come again.
So, okay, we have a data set of, let's
Hmm.
say, our data set has 4 columns,
Hmm.
three as independent as one and
Hmm.
one as dependent. We take the 3 columns into X, take the one
Hmm.
into Y. Then we take the 3 columns from X. Let's say we have 30 rows. So we divide it into S train, Y S tests. So let's say maybe 20 for train, 10 for tests.
Hmm.
Then we take our Y also, we divide it into Y train, Y tests.
Hmm.
Then we train on the S train and the Y train, and we
Hmm.
test on the S train
Hmm.
and the Y. Or how does it work?
The test,
That's
the thing is, uh, we will now predict on X test, right? X test was the dataset that was not used while the training, right?
yeah, yeah.
Now on this X test, it will predict your Y test. Are you getting it? Now it is this
Okay.
Y pred. So this is the predicted value. This is the
Yeah.
prediction, right? Y test is your actual value. This Y test
Okay.
is your actual, and this Y pred is your, I will comment it here for your better understanding. Y test is your uh, predicted value, right? And this Y
Okay.
test is your actual value. Actual value, right? Both are the Y test, but both are the labels of your unseen data,
Okay.
right? Are you
Okay.
getting it?
So what is S train and Y train? Can you put a comment on what is S train and Y train at the top? Yeah, yeah,
See, X train is your feature, or so you may say like a trainable feature, yeah, feature,
yeah, yeah.
right?
Y train.
And Y is your Y train is your label, like the predictable variable, like that we are trying to predict,
Okay. So
right?
that's the correspondence of the features in Y.
Yes, yes. So based on these X features, we will predict Y,
Okay.
right? So here now, based on X test, we are predicting Y test. Are you getting it?
So how do we get S text? That's the confusing part.
X test, we have separated this X train. This is 80%, right? This is 80%.
Yeah, yeah.
And this X,
Oh, then the S test is the segregated numbers of rows that we want to test on, we want to predict to kind of see what's,
yes, exactly, exactly, exactly. Right. So now this X test is 20, right?
yeah.
But not showing the Y. Hello.
Can you hear me?
I think my mic is fluctuating here. Hello.
Yeah, I can hear you. I can hear you. I think I had someone come into the call.
I'm audible, right?
Yeah, 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 I can hear you. So S test is the 20%. Then what is Y pred?
Y pred, yeah. So pred will be also 20%. This complete will be 20%. Here we are predicting all the text, right? Whatever but
Yeah.
test there is, we are predicting them all. There
Okay.
are just like suppose here are 20 values. Here we are predicting all those 20 values,
Okay.
right? So this is like complete all the 20%, all the remaining unseen data, right? Suppose, hello, hello.
Yeah, I can hear you. I can hear you. I'm hearing you. If I can't hear you, I'll let you know. But I'm just trying to understand this log. So
Okay.
now, let's say we've taken X, which
Hmm.
are the independent features. Then we've taken Y, which is the predicted feature. Then
Hmm.
out of the S, we've divided it, we've split it into 80 to train on this 80, which is the S train and Y train. So those 80 we're training on, we're kind of going to give the model the answers to those 80, which is the Y train, to kind of,
Hmm.
okay, this is the S train, and these are the results for you to train on. Once the model has done that, then we'll not create a Y prediction. So the Y prediction is to predict, to take what it has learned from those training data to predict the 20% that are in the test, the remaining 20% from the train data, which we now call S tests.
Hmm. 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 Yes. Now remaining is the 20%. That is X test, right? X
Okay.
test and XY. Sorry, Y test.
Maybe if you can
Now
leave a
we
comment
will,
to say the remaining 20% from the S train is called the S test.
okay, should I just give you a quick, again, a quick demo of a quick explanation of this again? Do you need that?
Yeah, yeah. Besides that, if you could just leave a comment to this code also,
Okay,
it's gonna make me because
sure.
I could forget easily, but yeah, that's fine. Go ahead, please. Because the only part I understand it up onto is the S train and the Y train, or X and Y. To be honest, those S train and Y train, I'm just beginning to
See,
understand it a lot better.
your data set is like this. Data set, suppose it contains 100 rows, right?
Yeah,
Now this row will be your x1, x2, y, right?
yeah,
And this is up to 100 rows, right?
yeah.
Now these two are your independent variables, right? Or features, right?
Yeah,
This is your test. Sorry, not test, it is your label, right? Now here we are dividing in the train test. This 80% will be used for your training, and this 20% will be your for your
test.
testing, right? Now in this training we have both x and y, right? This part is x and this is y, right?
Yeah,
Now if you see, we have this 80% and this we have 20%, right? Using this using this, we are giving this data to our model, and what this model is doing, it is learning this equation, mx plus c. So in a code we will see just a moment later. If you
yeah,
give your x value, it will tell you y, right? Here if you see, we have given it both x and y, so it is now learning this equation, right?
yeah.
What should be what should be m and c, right? Because once you
Yeah.
have learned that what should be the m and c, suppose say 2.5 and c is 5. Now based on this information you can tell what this y new, right, new y will be, right?
Okay.
If you will give, suppose say x is equals to some random value like x is equals to 2, x is equals to 2. Now you can tell the what is the y new value will be, right? Can you tell this? You will put this
Yeah,
value of x here and you can
yeah,
just tell, right? Like what the value of this y new will be,
yeah,
right? So here
yeah,
this is the equation, right? This is the important
yeah.
equation, right? So now here we have learned this parameter 2.5 and value of c, that is 5, right?
Yeah,
And now based on this, here this testing was just the x part, right?
yeah.
Here we only know x part. And what we
Okay,
are doing is, in the testing, we are hiding the y. We are
okay,
hiding the y. We are
okay,
getting the y prediction using this equation. We are passing in
okay,
the x. We are passing in the value of this x here, and we are getting the value of y prediction or y new, right? Let's say y pred. Okay.
okay.
So you will get value of y prediction, means you will get y pred for all these. You get this?
Yeah.
Now for this y x, you have y pred, right? The original
Yeah.
y you have not shown it to the ML model. This is hidden.
Okay.
The original or
Okay.
actual y. You
Okay.
got your y prediction from
Okay.
this equation, this linear regression equation, simple linear regression equation,
Yeah.
right?
Yeah.
Do you have any doubt till here?
To be honest, the statistics part, I don't think it really matters, but I'm understanding you. That's fine.
Mm. So can you tell me like how many values this y prediction will have?
So
X.
why prediction to have 20 values, which is from
Exactly.
the from
Exactly.
the
Exactly.
test.
Right. So y x will have 20, and for each corresponding x, we will have a y value,
Okay.
right?
Yeah.
And now, can you tell me like how we are going to evaluate it?
So I think how we're going to evaluate it is to kind of now look at the test value to kind of see what the actual y prediction, y the actual y that we needed from the prediction to compare it to what the prediction are and see
Hmm.
what the differences are.
Exactly. Exactly. So what we are going to do is we are find the distance or the difference in the y prediction and y actual, right?
Okay. Yeah.
Hope it's clear now.
Yeah.
Any
Yeah,
doubt
I kind of
or something?
understand that part, but in terms of X prediction, Y prediction, I only understood it to X independent variables, Y dependent variable, S train, take 80% from the train data. Because why I'm kind of asking is because when I start building my model, I want to kind of use validation before
Hmm.
test. I want to kind of break my data into SVAL, but I feel like that's in the
Hmm.
future anyway. But
Hmm. Okay, cool. So you saw there, right? Like we had this
yeah,
equation y is equals to mx plus c. I
yeah,
just talked about, right? That model is trying to learn, right? M and
yeah,
C, right?
yeah.
And if the interesting thing is, we used this equation to generate our data set. If you will see here, this y is equals to mx plus m that is 2.5 according to this equation, right?
Yeah.
Are you able to relate this equation here?
Am I? Yeah, I can read it.
You are able to relate it, right? M
Yeah.
x is this value, c is this value, and this is the noise, some random values, just to make it actual realistic, right?
Okay.
So due to this, there are
So the
some
value has to be between
error,
zero to two and 100 numbers. Is that what you
right?
mean?
Exactly. Okay. Okay.
Yeah.
So it will give some inaccuracies in between or some deviations, right?
Yeah.
So if you will see here, this only we are using it to train. So basically, this will have a linear relationship, y and x, right?
Yeah.
Now, do you can you tell it like if I give this equation or give this data to our this linear regression model, what this will learn?
Overfitting.
No. Mm. That will
Sorry, can you say
we'll
that
come to
again?
overfitting later. We'll come to overfitting later. But again, see, linear regression was trying to learn this, right? So can
Yeah.
you tell me what this coefficient will be?
Oh,
Do you know about
coefficient will
coefficient?
be, I think, M will be
Hmm.
coefficient. The number of coefficients is M.
Hmm. Hmm.
M1,
Hmm.
M2, X1, X2.
Hmm. 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 So how many m are there in this equation? One, right?
In this equation, the coefficient is 2.5.
Hmm. Hmm. Right.
Yeah.
And intercept is
Intercept should be like C.
Hmm. Hmm. Right. That is 5, right?
Yeah,
So this is what linear this model learned, right? The ln.fit we here did, and we passed this x train, this complete data, x train,
yeah,
right?
yeah.
And x test we have given to it, sorry, y train we have given to it. If I will print y, here I will do y. It will give me the list of y variables, right? And based on
Okay,
this have learned this equation. I have not provided this equation to our model, right?
okay.
I have just provided this data set, this x, list of x, and list of y. Here, just look at it again. In lin.fit, I provided list of x and list of y,
Why?
right?
Okay. Yeah,
I have not provided this value 2.5 and 5.
yeah, sure.
When I do dot fit, it will try to find this value,
Yeah,
right?
yeah,
And if it is able to find this accurately, this value and this value,
yeah,
that means your model is has high accuracy, right? And that is what
yeah,
it tried to do, right? It will try to find this value as close as possible. So if I do dot fit, now it have calculated the coefficient and intercept, right?
yeah,
Now, once it has, so once it has calculated the coefficient and intercept, if I will run this, you will see that it is how how far it is from this actual value. So this was a real value, and model have learned this coefficient and intercept. If I will run it, it will show you the values of that. Okay, I will
yeah.
just execute it, and you will see that there will be a some difference, right? And just a minute. See. Okay, cool. If I run this, you will see slope, that is
Yeah,
coefficient, is 2.52, right? Intercept is 4.6, that is close to 5, and this is
yeah,
close to 2.5.
yeah.
And the R score is,
0.95.
can you tell me like why it's the case? Because
Say that again. Can I tell you what?
can you hear me?
Yeah, I can hear you now.
Oh, yeah. Can you tell me like why not 2.5 exact?
Can I tell you why it's not 2.5?
Hmm.
Mm, no, I wouldn't be able to.
Why it is not 5 and why the intercept is not? Because
I can't hear you. You're breaking up. I wasn't hearing you. No, I can't see hear you. I can't hear anything. I can't hear you.
can you hear now?
Yeah, I can hear you now.
Okay, just yes. Okay, fine. So, mm, Getting my voice back. Okay, fine. So, yeah. So, can you tell like why this is the case? Like we are not getting 2.5 and we are getting value 2.52 because uh, we are giving the equation, right, and generating the data set using it and asking a model to predict,
Yeah.
right? So, can you see like what is the issue here? Or actually, that is the thing that we introduced.
Um, thing that will be introduced in what way?
Okay, let me try one thing. You remember this was noise.
Yeah.
So if I run this and then I run this, now do you see we are
Okay.
having a same 2.5 value, right?
Yeah.
So it is very interesting. See, here we just generated the data using this equation
Yeah.
and we got the values for x train like this. If I will give you the x train here, these values, right? For
Yeah.
x and for similarly for y as well, right?
Yeah.
I gave it the x train and xy, right? And
Yeah.
it is getting me the slope, the coefficient, and the intercept. This, and it is exactly same as this that we use for generating our data set, right? This
Yeah.
2.5 value. So basically, that means under the hood, this regression model uses this equation, right?
Yeah.
Does this make sense now? It's the coefficient, linear, right?
Yeah.
You can try to think again. It can take 10 minutes. We'll move to next step.
Okay, I can join back in 10 minutes.
Yeah.
Okay, that's fine. Take.
So just see like here, we gave it the x value and the y value to the model, the linear dot fit, and it learned the coefficient and intercept. And interestingly, this
Okay.
coefficient and efficient intercept is the same as what we use for generating our labels, synthetic, right?
Yeah.
So that means it learned the values correct. Earlier, what we did was we added this noise, some random values, due to which there was